All right, hello Austin. This is a solution to the problem we left off with yesterday evening. Okay, so it's going to involve using triangles and sectors. The first thing I'm going to do is draw a line from here to here. Okay, and then I'm going to draw to the center of the circle and to the center of this circle as well. Okay. Actually, I'm going to get rid of that line real quick. Let me see if I can do that. Bang. I don't want that yet. Okay. And I think yesterday I had talked about the area of the gray and the pink right here. This whole area here. So this pink and this. So it's just part of the circle. Okay. So that area, so I'm just going to do the smaller circle just to keep this organized. Smaller circle um, sector. So that's just like a piece of the pizza there. Okay, so since this arc right here is 90 degrees, that means that this is exactly 1/4 of the circle. Okay, so that means the area of the pink and the gray is equal to 1/4 pi r squared, since it's 1/4 of the circle. So that is going to be equal to 1/4 times pi times 3 root 2 the quantity squared, which is equal to 1/4 times pi. 3 squared is 9. The square root of 2 squared is 2. So that's going to be 18 pi over 4, which simplifies to 9 pi over 2. Okay, so I need to erase to show you what we're going to do next, but remember this is the area of that entire sector. So I'm going to get rid of a bunch of this stuff. Okay, just so I can draw again. Okay, and now I'm going to draw a triangle. Okay, so again I'm going to connect this, which I did before, and this one and this one. Okay, and I'm going to find the area of that triangle, because why am I going to do that? If I um, can find, wait, let me back up. 9 pi over 2 is all of this area. I'm not going to color it in because I don't want to. Is all of this area, okay, from along these lines. It's the area of this sector. Well, if I can find the area of the triangle and subtract out that area, there's a reminder, I don't want to go to that meeting. If I can subtract out the area of the triangle, I am left with this little piece of the gray area right here. Now that's not all the gray area, but when I go over to the big circle, I'm going to be able to use the exact same strategy, and I'll get the other side of this little gray area. And I'll show you that step by step here in just a second. Okay, but right now I'm going to focus on the area of this triangle. Okay, so let me clean that up a little bit. Let me undo. Okay, so I know that from here to here is 3 root 2. And I know that this angle right here is 90 degrees. How do I know that? Because the measure of a central angle is equivalent to measure of its the arc that it cuts off, which we're given as 90 degrees. This is a radius of a circle, so it's also 3 root 2. So, oh, I put a 3 root 2. So I can get the base here of the triangle because area of triangle, and this is I'm just going to keep this under the smaller circle sector, is equal to 1/2 base times height. So I got to find the base. Okay, so I'll call this B for now, and I know that this is our answer that we're headed towards, by the way. So let's see. I know that B squared equals, by the Pythagorean theorem, 3 root 2 squared plus 3 root 2 squared. So B squared is going to be equal to, that's going to be 9 times 2, so that's going to be 18, because 3 squared is 9, root 2 squared is 2, 9 times 2 is 18, plus 18, yes? So B is equal to the square root of 18 plus 18, and 18 plus 18 is 36. So my base is equal to 6. This is excellent news. So I'm going to go ahead and label that as 6. Okay. Well, now I need the height of the triangle. And it would be nice if that was 3 square root 2, but it's not, because it's not a full radius. But I do, if I pull out that triangle there, I'm just going to pull it out right down here. Okay. I know this is 3 root 2. I know that this is 90 degrees, and I know that this section right here is 3, because the full length is 6. And if I drop a perpendicular to a chord, which is what I did, it bisects that chord. That is a theorem. So if it cuts 6 in half, from here to here is going to be 3. Okay, so I can get the height here using the Pythagorean theorem. I'll just call that x. So x squared plus 3 squared is equal to 3 root 2 squared. X squared plus 9 equals 18. X squared equals 9, so x equals 3. So I know that the height is 3, B is 6, H is 3. Okay. Now the other thing we could have realized here is that this is a 90-degree angle. This is going to bisect this big 90-degree angle, which makes this 45 degrees, and which would have to make this 45 degrees, because the sum of the angles in a triangle equals 180. And what we have here is a 45, 45, 90 triangle, which has a special relationship. And that relationship is, if this is of length, say, K, like K, this is going to be K, because it's isosceles, obviously. I guess I didn't have to do that. I could have seen it's isosceles and then just seen that this is 3 immediately. I didn't have to go through this, because if I realize that these are both 45, then, and I know this is 3, this has to be 3. And also in a 45, 45, 90 triangle, if you know these two sides, then the hypotenuse is this side times 3 root 2. So there's a lot of different ways we could have done that. Sorry I took the long way. So the area of this triangle is going to be 1/2 the base, which is 6, times the height, which is 3. 1/2 times 6 is 3. 3 times 3 is 9. Okay. So again, the area, and I'm just gonna call this pink for now. So the area of pink, the pink sector, or the pink section I should say, is equal to the entire sector, and I'm going to cut away the triangle, and I'm just left with that. So that would be 9 pi over 2 minus 9. And I'm just going to leave that alone for now, because now I have to do the same thing to get the area of the blue sector. Okay? So I am going to, I think I'm going to duplicate that. That's what I'm going to do. See if I can't, oops. Let me undo that. Let me see if I can grab, darn it. Come on, Becker. Okay, so I'm going to do this. I'm going to try and move this work over just to save it, so you'll have it if you need it. I'm going to take this back to where it was. Nope, that's wrong. It was here. Okay. And I'm going to erase this blue, kind of redraw everything just so you have it. Okay, so this went down to here, and so I have area of pink, and I knew this was 3, and I knew that this whole length, I'll put that in blue so we can see it, was 6. Okay, so now I am going to just copy this, and so we can work with it again and move it down here. Okay, and so now I'm going to do the same thing that I did on the other one here, and I'm going to draw this base here, okay, and I'm going to draw this radius here, and I'm going to draw this radius here. Now remember, from our previous work, we already know that this length is 6. From here to here is 6. So this is of length 6. This is 6, and this is 6. Okay, which means it's an equilateral triangle, which means this angle right here is 60 degrees, or 1/6 of the entire circle. So that means now we're going to do the larger circle sector, which is this one, all the way around here. So it's like this ice cream cone I'm going to find the area of, and that's just, it's 60 over 360, or 1/6 the area of the whole circle. So that is going to be 1/6 times pi r squared, which is 1/6 times pi times 6 squared, which is 36, which is going to be 36 pi over 6, which is equal to 6 pi. Booyah! Okay. And now, oops, I was trying to underline that. Let's see if I can do a better job. I bet you I can. I am that good. Look at that. Oh, so much better. And now I'm going to find the area of this triangle. Okay. So the area of the triangle is 1/2 base times height. Okay. So I have to drop a perpendicular to get the height. I know that from here to here is 3. So if I call this x, then a little bit of work underneath here, x squared plus 3 squared equals 6 squared. X squared plus 9 equals 36. I'm going to go over here. X squared equals 27, subtracting 9 from both sides. So x equals root 27, which I'm going to simplify that radical. X equals square root of 9 times 3, rewriting 27 as 9 times 3. So I can simplify that radical because the square root of 9 is equal to 3, and I'm going to write that as 3 root 3. So that's the height of this triangle. The base is 6, so that's going to be equal 1/2 base, which is 6, times height, which is 3 root 3. Okay, and so that will be 1/2 times 6 is 3, times 3 is 9, so that's going to be 9 root 3. So now the area of this blue sector right here, okay, I can get that by taking the area of the entire sector, which I have here, which is 6 pi, and if I cut out or subtract the area of the triangle, which is 9 square root 3, I get the area of the blue sector, which is the other half, or the other part here. It's not, I don't want to say half because it's not exactly half. It's the other part here. So area of blue is equal to 6 pi minus 9 root 3. Okay? And so I'm going to work out total area right here. Total gray area, because that's what it initially asked for, is going to be the area of the pink, this, plus the area of the blue, this. So that would be 9 pi over 2 minus 9. That's the pink. I suppose I should have written it pink, but I think you can handle it. Plus 6 pi minus 9 root 3. So I can't combine the 9 and the 9 root 3, but I can combine the pi's. So that would equal, I should have an equal sign there, equals. So that would equal 9 pi over 2 plus, I'm going to rewrite 6 pi with a denominator of 2. So that would be 12 pi over 2 because 12 over 2 is 6. Minus 9 root 3 minus 9. And looky what we get. Equals 9 plus 12 is 21. So that's 21 pi over 2 minus 9 root 3 minus 9. And there you have it. That's the answer that they have here. Hope you understand it. If you don't, shoot me an email and we'll try and set something up to help you understand. All right, I am out.